Hi, I'm Divya. Myself and my team members are here to present on a paper Coffee. Coffee is nothing but a code fixing with feedback, which boosts your large language models by fixing bugs with feedback, which was originally presented by Sengjun Moon and his team. As AI driven became a more popular, their ability to accurately detect and fix code errors is becoming difficult. Closed source large language models like GPT is providing corrective feedbacks. This research aimed them to bridge the gap by improving the open source code LLMs through structured data set and optimized feedback generation. Why did we think this topic is important? Because it has a unique and practical approach which initially sparked interest in us. Unlike general code generation studies, Coffee focuses on the feedback driven correction. This research directly improves the AI assisted debugging and editing. And the open source helps to dominate the AI assisted programming. By improving the open source promotes transparency, accessibility, and innovation. This also improves the software reliability, which more accurate AI generated feedbacks can reduce bugs and enhances the software development efficiency. It also encourages the AI adoption in development. With better AI driven coding assistance, developer can streamline workflows and focus on high level problem solvings. It enhances the open sources LLMs benefiting for educational tools, enterprise development, and software maintenance, which will help the widespread to use. And uh, the first and foremost example which we have seen is in code LLMs model often gives a misleading feedback which fixes error in source code. Here, there is a mistake which cannot be rectified easily, but it is also be rectified with the feedback. This is this is why they wanted to implement in Coffee. They may point out the wrong mistake and suggest an incorrect solution leading to the poor fixes. This happens because these models are trained on general code data, not specifically on tasks to code editing. To solve this, we aim to create a high quality data set with natural language feedback that can improve code editing. And the challenges and gaps that they have faced are many. Some of them are like it has a limit. The challenges which already existed is limited error detection. In open source LLMs, struggles to identify the critical programming mistake leading to unreliable code. The then how the Coffee resolved it is by Coffee dataset development, which provided a specialized dataset with high quality annotations to improve the ability of LLMs to detect and correct errors. And when the ineffective feedback generation was uh, had a challenge, many open source models generated vague or incorrect feedback and many debugging difficulties. When the coffee pot framework came, it introduced a structured approach for aligning feedback generation with correct code edit, ensuring more precise or useful guidelines. When the lack of structured training data of the open source LLMs lack high quality, the data sets limiting within learning and performance, the coffee data set specifically was trained by the LLM in code editing, helping and generating more accurate feedback. When the performance gap between the open and source code models came across, it lagged behind one of the accuracy and reliability. But in the coffee pot, it prefers optimized tuning, and selection, which helped the performance benchmark like human naval fix. With with of course, we know that human naval fix will be helps to rectify by feedbacks. When the limited open source contribution acted as acted as if it is without access of high quality data and model research, and developers struggle to improve the open source LLMs. But here in because of the coffee, the open source availability for the coffee and coffee pods are publicly released, encouraging further researches and community driven improvements were implemented. Now, my teammate is Irisha will continue.
I'm Iresha Bandarnaik Himhemutyan. Let's talk about summary of novel contribution. First, the coffee dataset. The coffee dataset for code editing with feedback, which is a specialized dataset designed for training LLMs to provide structured feedback for correcting code errors, and improves the ability of open source models to generate actionable and accurate corrections. Then the state-of-art performance in code editing benchmarks, which achieves the superior results on human eval fix and other code repair benchmark, and demonstrates that open source LLMs, when fine-tuned with coffee, can match or surpass closed source models in certain tasks. Then, CoffeePot framework. This introduce code fixing with feedback via preference optimized tuning and selection, and aligns feedback generation with correct code edits, enhancing model performance in real world scenarios. Finally, open source contribution for research community, which publicly released the coffee dataset and coffee pots framework, encouraging further research and innovations, and support transparency and collaboration in AI assisted programming. So let's move to the literature review. Uh, in this slide, we summarize the related work done in this research, which is focusing on how LLMs handle code generation, repair, and feedback augmented editing. When considering code generation, LLMs like Codex, introduced by Chen and the team, can generate uh, code from natural language descriptions, and recent improvements such as instruction tuning introduced by Rosia and the team enhance their capabilities. And however, correcting critical errors in generated code remains challenge, it, which mentioned by Lee and the team. Then code repair. Uh, LLMs have also been explored for automatic program repair, which introduced by Fan and the team. And one effective approach is incorporating feedback from tools like compilers, which improves the model's ability to edit and refine code, which introduced by Gao and the team. Then feedback augmented editing. It is inspired by it's inspired by reflective feedback techniques introduced by Madan and the team, and Sang and the team in 2023 proposed using open source LLMs for feedback augmented code editing. So this approach addresses challenges related to API cost and security, then making open source solution more viable for real world applications. So these studies highlight both the progress and challenges in LLM driven code editing. While existing methods show promise, they often struggle with critical error correction. This research builds on these insights by introducing Coffee dataset designed specifically for feedback code editing, which is aimed to improve the effectiveness of open source LLMs in fixing code errors. Then let's move to the methodology of the research. Uh, The Coffee framework leverages several key methodologies to enhance code editing and bug fixing using open source language models. Uh, First, on open source LLMs. Coffee specifically uses open source LLMs to avoid the limitations of closed source models, such as high API cost and security concerns. Open source models allow for more flexibility and accessibility in integrating integrating feedback. Then feedback augmented learning. This methodology involves incorporating real world feedback from developers into the model's learning process. When a developer provides correction or suggestions, Coffee uses that feedback to adjust and improve the model's code suggestions, ensuring the continuous enhancement of the model's performance in code editing. Then the reflective feedback generation, which drawings uh, this reflective feedback generation drawing from prior research on reflective feedback generation, which introduced by Mardan and the team in 2023. Coffee generates natural language explanations for code errors it identifies. These explanations help developers understand the issues more clearly, enabling more informed correctness and improvements. Then compiler integration to further enhance its code editing capabilities. Coffee integrates feedback from external programming tools like compilers. By using tools that analyze the code and provide insight into potential errors, Coffee can identify bugs more effectively and offer more precise corrections, combining the power of LLMs with traditional debugging tools. So, together, these methodologies make Coffee a robust and effective framework for improving code quality through feedback and iterative learning, while addressing the challenges of API cost and security issues associated with closed source solutions. Then, Isuru will describe key findings or outcomes.
Hello, I'm Isru Holupathredi. Today I'm excited to introduce Coffee, a feedback augmented learning approach that enhances software development by improving bug resolution, code review, and overall code quality. And the findings and outcomes are scalability, improved code accuracy, natural language explanation, enhanced debugging efficiency. When we come to the scalability, one of Coffee's strengths is scalability. It's adapt various coding environment and problem domains, making it a powerful tool for real-world application. Whether you are working on a small script or large-scale software system, Coffee can integrate seamlessly. On the next one, improve code accuracy by incorporating feedback augmented learning. Coffee significantly enhance code accuracy compared to traditional models. It provides more precise code solutions and efficient bug fixes, ensuring higher quality software development. And the natural language explanation, standard feature of Coffee is ability to provide natural language explanations for errors. These reflective feedback mechanisms help developers to better understand issues and make informed correction, improving both learning and productivity. And the last one, enhance debugging efficiency. By integrating compiler and programming tools, Coffee accelerate bug detection and resolutions. This combination ensures that errors are caught early and fixed accurately, saving valuable development time. On the next one is relevance. Bug resolution, code and refactoring, quality control mechanism, reverse engineering, and code reuse. When we come to the bug resolution, Coffee enhances bug fixing by leveraging feedback loops to identify and correct errors efficiently. This aligns perfectly with our course focus on resolving software bugs using the latest tools and techniques. Code review and refactoring. Through refactive and comply-based feedback, Coffee enables developers to conduct through code reviews and refactoring, ensuring cleaner and more maintainable code. On the other hand, quality control mechanism. Copy support quality control by leveraging LLMS and external programming tools to validate code correctness, readability, and performance, ensuring software meets higher standards. On the last one, reverse engineering and code reuse. By improving code understanding through feedback-based errors explanations, Coffee aids in reverse engineering existing code and reusing components, a crucial aspect of modern software development. When we come to the implications, enhanced AI coding assistance, more reliable AI-driven tools for developers, and better open source AI models encourage broader adoption of open source programming assistance, reduce debugging time, faster and more accurate code fixes. The impact on education is improved AI-powered learning tools for coding students. These are the research papers and web application that we went through, and we have mentioned the references here. And the papers are between 2019 to 2021. And the authors are Chen, Guo, and Li. And we have also mentioned the website that we have used to get the details and information. And thank you.